Welcome everyone. I am C.SAMPATH Kumar, Assistant Professor, Department of Mechanical Engineering, Rohini College of Engineering and Technology, Hall Club, Kanyakumari. In this video, we are going to discuss about the subject ME8651, Design of Transmission Systems. In this, we are going to discuss about the Unit 5, Cams, Clutches and Brakes. On that, the problems are based on the clutches, which is single plate clutch problem. Problem number 1. Design a dry single plate clutch is to design for automobile vehicle whose engine is rated to give a 100 kW at 2400 rpm and the maximum torque 500 Newton meter. The outer radius of the friction plate is 25% more than the inner radius. The intensity of pressure between the plate is not to exceed 0.07 Newton per mm square. The coefficient of friction is 0.3. The helix spring is required by a clutch to provide an axial force necessary to engage a clutch of 8. If each spring has a stiffness is equal to 40 Newton per mm. Determine the dimension of friction plate and initial compression of the spring. First, given data. The power P, which is equal to 100 kilowatt, which is equal to 110.3 watt. Speed n is equal to 2400 rpm. The maximum design torque whole bracket is T is equal to 500 Newton meter, which is equal to 510.3 Newton mm. Intensity of pressure P is equal to 0.07 Newton mm square. Coefficient of friction mu is equal to 0.3. Stiffness of the spring K, small k is equal to 40 Newton per mm. Number of spring n is equal to 8. Outer radius, which is given that from the question, small r1 is equal to 1.25 r2. To find out outer radius r1 and initial compression solution, we know the formula. Axial load W is equal to 2 pi c r1 minus r2 and the torque whole bracket T is equal to mu n W r. We know the spring index C is equal to P max into small r2. P max, which is the intensity of pressure, which is given that 0.07 into r2. By using the formula, axial load W is equal to 2 pi c into r1 minus r2. Substituting the values of r1 and c, we are getting W is equal to 2 pi into 0.07 into r2 into 1.25 r2 minus r2. We are getting the axial load W is equal to 0.1099 r2 square. We know the formula. Mean radius or capital R is equal to small r1 plus r2 divided by 2. Substituting the value of r1, small r1, we are getting that 1.25 r2 plus r2 is equal to divided by 2, which is we are obtaining capital R is equal to 1.125 r2. We are then substituting the value of in equation, torque whole bracket is equal to 500 into 10 power 3, which is equal to 2 into 0.3, the value of coefficient of friction, and W we find out the axial load, which is equal to 0.1099 r2 square into 1.125 r2. Substituting, and we are getting r2 is equal to 188.896 mm. We are round offing the value. R2 is equal to 190 mm. Therefore, R1 is equal to 190 into 1.25, which is equal to 237.5. We are round offing the value, and R1 is equal to 240 mm, and W is equal to, we are substituting the value in equation 1. W is equal to 0.1099 r2 square. We are obtaining the value W is equal to 3967.39 Newton, and the total stiffness equal to small k into n, which is equal to 320 Newton per mm. We know the formula of initial compression, which is equal to axial load by total stiffness. Axial load is equal to 3967.39 divided by 320. We are obtaining the initial spring compression is equal to 12.398, which is round off in the, we are getting the initial compression is equal to 12.4 mm. Now we are going to write on the result, that is outer radius R1 is equal to 240 mm and the initial compression is 12.4. Thus the problem is solved. Thank you.